Alright, we're going to be reviewing for your Chapter 3 test here. Our first question here is to solve the system by graphing. So we're going to solve each of these lines for y and then graph the line. So the first one, we're going 2y and we're subtracting the 4x on both sides. So negative 4x plus 10. We divide everything by 2 and we get a negative 2x plus 5. So I have a y-intercept of 5. I'm going to put a little dot right there. Up 2, left 1. Up 2, left 1 to indicate my negative slope. And I'm going to go down 2, right 1. I'm going to go down 2, right 1. And I'm going to keep going just to ensure accuracy. You don't have to go this far, but I am just to ensure the accuracy of my graph. The more points you do, the more accurate you will be. So we'll start here. We're going to come down to this line right here. And that's what my line should look like. Now obviously we're looking for an intersection. That's going to be our solution. So when I do my second line, I'm going to end up with negative 4y equals a negative 6x plus 8. And now I'm going to divide everything by negative 4. Negative 6 over negative 4 is a positive 3/2. And then 8 divided by negative 4 is a negative 2. So now my y-intercept is a negative 2. And we're going up 3 over 2. Up 3 over 2. Up 3 over 2. Up 3 over 2. And on this side, we're going down 3, left 2. Down 3, left 2. Alright, so now we come here. And you notice that point of intersection, which is right here. And that's at point 2, 1. So my answer to this question would be 2, 1. And that's the point. That's my answer. A little box around it, so we no question as to what the answer is. Oops, I have to do that again. Let's do this. Okay, so in terms of our sorry about that. In terms of our using substitution to solve a system, we're going to solve for whichever variable is a 1 coefficient. So in this case, I'm going to go y equals negative 3x plus 12. And now I'm going to take that y and plug it into my other equation. So 4x minus 5, always in parentheses when we plug it in, negative 3x plus 12 equals a negative 3. This becomes 4x plus 15x minus 60 equals a negative 3. We're going to combine like terms. 19x minus 60 equals a negative 3. 19x equals 57 when we add 60 to both sides, and my x equals 3. Now do not forget, once we get x, we do have to get y. Plug back into an original. 3 times 3 plus y equals 12. 3 times 3 is 9, plus y equals 12, and my y equals 3. So now I have my answer of 3, 3, and that is my point. So 3, 3 is the answer. We write it as a point. And let's establish that's the answer. So my point 3, 3 is my answer. Now when I go to solve the equation by system through linear combination, or go to solve a system's equation through linear combination, now I need to get rid of one of the variables. I'm a big fan. It doesn't matter whether you get rid of the x or y, but if signs are opposite, that's usually the one I go with, unless it'd be much easier based on the numbers. Since regardless of whether I get rid of x or y, I got to multiply both equations, I'm going to get rid of the y because they have opposite signs. And all I'm going to do is I'm going to take the coefficient in front of the y in the bottom equation, multiply it up top. And then I'm going to take the coefficient of the y in the top equation and multiply it on the bottom. And since they have opposite signs, I don't need to worry about multiplying anything through by negative. When I multiply through by 7, I get 35x minus 21y equals a negative 77. On the bottom, I get 12x plus 21y, which is nice, the y's will cancel, equals 30. Now, when I combine my like terms here, I end up with 47x, the y's cancel, and I'm left with a negative 47. And my x equals negative 1. Now I need to place it into an original. 5 times negative 1 minus 3y equals negative 11. Negative 5 minus 3y equals a negative 11. I'm going to add 5 to both sides, and I'm going to get negative 3y equals negative 6. And now I divide both sides by negative 3, and my y equals 2. So my answer here is going to be negative 1, 2. And one other piece of this is it should work for both equations if you want to check it. All of these should if you want to check them. 4 times a negative 1 plus 7 times 2 equals 10. 5 times a negative 1 plus 3 or minus 3 times 2 equals negative 11. So I know my answer is correct. Alright, now we're going to do systems of equations with a word problem. So in these cases, we want to establish what variables represent. In this case, X represents an adult ticket, and Y will represent a child ticket. So when I set this equation up, make our numbers a little bit smaller here so we can fit everything. Okay, when I set this equation up, I want to know how many tickets I have. Well, there's 400. And those 400 tickets come from adult tickets and children tickets. So X plus Y equals 400. The revenue collected is $2,350. So that comes from $7 for every adult ticket and $4 for every child ticket. Every adult ticket times 7 gives you your total revenue for adult tickets. Every child ticket times 4 gives you your revenue for child tickets, and together it's $2,350. And essentially I have a system. Now when I have the opportunity to, you absolutely can do substitution here, but I have always been a big fan of linear combination if you give me the choice. So in this case, I'm going to multiply the top equation by a negative 4. And when I do that, I get negative 4x minus 4y equals negative 1,600. And I get positive 7x plus 4y equals 2,350. Negative 4x and 7x is 3x. The y's cancel, and 2,350 minus 1,600 is 750. When I divide that by 3, 750 divided by 3 is 250. So there are 250 adult tickets and there would be 150. What plus 250 gives you 400 child tickets. And that's how we use a system to solve our problem. Box that number up. Here, we have an elevator with 2 types of boxes. Box A will be represented by X. Box B will be represented by Y. There are 21 boxes between Box A and Box B. So that's X plus Y equals 21. The weight of Box A is 45. The weight of Box B is 65. And together, those total amount of pounds between 45 times the 45-pound boxes and 65 times the number of 65-pound boxes, that total weight adds up to 1,205. And once again, we're going to do our system. So I'm going to multiply the top and the bottom, or not the top and the bottom, just the top, by, in this case, a negative 45. And that allows me to get rid of my x. So when I multiply this through, I get negative 45x minus 45y, and that equals 21 times 45, which is a negative 945. Below that is simply 45x plus 65y equals 1205. The x's cancel. Negative 45 and positive 65 is a 20y. And 1205 minus 945 leaves me with 260. When I divide that by 20, we have y equals 13. So that means there are 13 65-pound boxes. And what plus 13 gives you 21? That's 8. So there are 8 45-pound boxes. Make sure you're answering what they're asking for. If they're asking for A boxes, make sure that's what you're giving them. If they're asking for the B boxes, make sure that's what you're giving them. If they ask you for both, make sure you give them both. Alright. Now we're going to graph systems of inequalities. Our first step is still to graph the line as we normally would. So this becomes 3y is less than negative 2x plus 9. And then we divide everything by 3. Y is less than negative 2/3 x plus 3. I'm going to take my second equation, or second inequality, negative 5y. We're going to subtract the 4x on both sides. And that becomes greater than or equal to negative 4x plus 10. And then we divide everything by negative 5, so we flip the inequality. And we end up with a positive 4/5 x minus 2. And I'm simply going to graph those lines. So positive 3, and we have negative 2/3 as a slope. Up 2, left 3. Up 2, left 3. Up 2, left 3. Down 2, left 3. Down 2, left 3. Down 2, left 3. And that is a dotted line, because the thing is just less than. So here we go. And we do need an arrow on the other side. I don't know why they don't give me a choice of giving you an arrow on either side, but that's what it should look like. My second line, 4/5 x minus 2. So negative 2 is my y-intercept. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a solid line. We start here and go through. Okay, and now we have to shade. We'll shade using these lines. And what I like to do is I like to plug 0, 0 into the original. So 2 times 0 plus 3 times 0 is less than 9. So 0 is less than 9. That's true. So we shade toward the 0, 0. So when I shade toward the 0, 0, I'm just going to shade this way. My second one, 4 times 0 minus 5 times 0 is greater than or equal to 10. So 0 is greater than or equal to 10. And I would argue that is false. 0 is not bigger than 10. So now I'm going to shade away from 0, 0. So I'm going to shade this way, away from 0, 0. And this right here is the answer. It's the double shaded region, right in this here area. Just put it over there a little bit. There we go. Okay. And that's your answer.